So I'm coming here, and this time I'm changing the stiffness of the slabs to very low stiffness, say 0.001, very small, 0.001 and 0.001. Okay, and I will do the same intentionally for 200 slab. It's not correct. I just want to show you what's happening, guys. As I said, I try to be visual in my courses. I want to show you the consequences of using different options, so that will help you to understand the behavior of the structure better. So I'm running this model again. Okay, so what we did, we reduced the stiffness of the slabs significantly. The consequence is having some shifts in frequencies when the model analysis is being done. To avoid of these, as you saw, I deactivated running model analysis to save the time. So it's done. Now we coming here, and I will show you also the deflection here. I'm coming here, going to frame, and using the same moment, come UG2 and apply it. Now this number comes to 70. It was just 5 or 6, so it's 10 times of before. Here is 125, is almost twice. It's not as significant as this because those didn't take any load. This beam, because of using a stronger section and have a more stiffness, a slab transfer load to this directly last time. But now you see the moment from 62 changed to 124, here from 5 or 6, maximum 7 changed to 70 kilonewton meter per meter. So what's happening here? Just click here and press apply. So here we had 62, we have 87 now, so the change is not significant. You see it's a bit more, but not that much. Here change, yes, from 24 changed to 33, so this one is just 83. So really back to the compatibility of deformation and how the loads will be transferred. For this slab, is that realistic to use such a low stiffness? My answer is no. The reality is the slab can take the load, and the slab is able to transfer load to the corner. Yes, beams are working, but when the span is such a large span, we cannot expect that the slab deflect that much. So my suggestion is keep the beam 0.7, but keep the slab 0.35 as it was at the beginning. Here, because you want to design the beams, you can be very conservative and you can use this low factor to design the beam. So easily you can calculate manually and see what load you are expecting to be transferred here, and for a simple span beam what would be the maximum moment, and then when you have it you can compare here the result. We can have a look at the slabs. So I'm coming here and put the slab in view, apply here, I'm coming and apply, and now I'm checking a slab. So I'm using M22 as before, just to keep it the same with the same range. Here I'm coming and apply the same as before. Let's see what we have. So here the moment is very small. Literally you don't have that much moment, but you see the moment changing from negative to positive. That means the shell is spanning between beams. Here what's happening is 7, so the moment is smaller, and here it's just less than 1. That means all loads will be transferred here to the beams, and you don't have that much transferring load here to the slab. So a slab is not taking too much load. What about the deflection? So the way we use here, if you remember, we auto-mesh the shell to the beams and we had dummy joints, and also we auto-mesh the frame to get those nodes, see if the nodes are detected or not. So if I come here to displacement and use Compass G2 and apply, and use a start animation, you see they are working together. How we can make it more clear? I can come here, I can go to user define and change this factor to 10. Yeah, so it's more clear now. So what I will do, I will zoom in a little bit and now I am doing this and start the animation. You see the beams are properly moving with the slab. That means the beam Automesh detect the dummy joints of the slab Automesh. So this system works well. See what's happening here. Yeah, I'm not surprised of such a big deflection on the slab because the stiffness is very low. So if I go to animation, so regardless of significant move in a slab, you see the beams are properly connected and they are moving. The movement is not considerable and is not very visible because currently a slab is moving very hard. So what we need to do, we can change the stiffness to a reasonable stiffness and then see what's happening here. So you saw that the moment we had here for beams was not changed as much as here. So here the moment from 62 changed to 80, so something around say 30 to maximum 40% increase. Some of them increase more. Here we had 24, I think now it's 84. Now we're changing back to 35, so we keep it 0.35 for these slabs. Here we can keep it 0.001 or something like that. We can't say a slab is not transferring any load here, but you can be a bit conservative and get the maximum load for beams and then change it and get the load for the slabs. So I'm coming here and changing this 200 slab to 0.35. So I'm happy with this. I believe we didn't touch 250 slab, just double checking because I don't want to back again. So that's correct, and the columns and walls are 0.7, which are correct. Here, just to show you what happened if you use membrane, because membrane doesn't have any stiffness at all. So see what's the difference if you use 0.001 or membrane. So let's come in here and change this one to membrane and then run it one time more. I'm trying to cover all scenarios for you guys just to ensure that you are clear about the basic of modeling and design, and hope those trial and errors can add value to you, and I look forward to receive your feedbacks about this method of education. I believe we need to see the mistakes to be able to avoid, otherwise just saying about that and going ahead and just talking about what is really correct, it doesn't help us that much and we may easily forget those mistakes. But when you see the consequence, it's easier for you to remember and compare the result. Even sometimes you may make a mistake. When you know what's the cause of such a big moment or a small moment, it's very easier for you to detect, okay, I applied the stiffness factor wrongly. Okay, we have warning now, and the warning coming because of using membrane, because this is a kind of ill condition or unstable condition. So if we have displacement here, compass G2 and apply, so you see how much is deflect, because membrane has zero stiffness out of plane, so we shouldn't use it. Okay, that's all I wanted to show you. Don't be surprised when you see an error, because the number is massive and I use a scale factor of 10. So if I back to automatic, it will be scaled reasonably by software, so you can see a better number here, so you can see how much it moves. But it's clearly, you see, it's a good sign to see that the shell is detected by beam, and you see just this area between beam is moving, and because this movement is too much, scaling to the deflection of the beam is literally zero deflection for beam visually, so that's why you see just the shell is moving. Okay, that's really good example, and let's back and again change the stiffness to reasonable amount. So I change it to 0.01, just 1%, which is here. Okay, so I just need to back to shell thin and press OK and OK. So I use 0.01. Let's see what's coming up, because last time you remember the moment here was 70. Okay, it's finished. Now we can see frame, comb UG2, moment 33. See what's coming up. 47, 48. That means even that 0.01 gives you a significant change in transferring load. So if you really want to transfer all loads to the beam, 0.001 is the correct one, which was about 70. So I think that number was correct. But again, what is the reality? You really need to see what is the stiffness of a slab here, how much load can be transferred by a slab to the support, and what is the actual stiffness of the beam here. Is the actual stiffness of the beam here correct? The answer is no, because this beam is acting like a composite beam. This beam has a flange of the slab on top, so we need to modify the stiffness of the beam. We will talk about it in the last part of our module about design of composite beam and design of steel beams. So be patient and I will get back to you on this. So what is correct currently? If I really just want to design the beams, I need to back to 0.001, but it shouldn't be 0, because that really affects the result of model analysis. So what I need to do, I need to again just unlock the model very quickly, change this factor to 0.001, and also this time I want to run all load cases. So I'm coming to analyze and set load cases and run all. I press OK. Now the model is ready to run. In the next video, I will show you how to complete your sections in terms of reinforcement detail and make them ready for the design, and also how to set the design parameters, and then we will run the model and do the basic check before going to the structural design of elements.